So a little bit on corrosion, not loads and loads. I think you all know that iron can corrode. When iron corrodes, we call it rust. And iron rusts when it combines with water and oxygen from the air. And by the way, it rusts faster when you've got salty water, and you don't need to know why. But rust essentially is iron oxide or hydrated iron 3, in other words it's iron 3 plus oxide, right? So you need to know that fact, that straightforward fact, and you need to know that there are ways of preventing rust, and we'll talk about those in a little bit of detail. Now there's an experiment that you would have done or seen about how you can work out the factors that affect rusting, and I'm not going to talk about that really at all, right? So this is a practical skill one, but where you put iron in circumstances where there's water or no water, or it's dry, or there's air or no air present, and only when there's iron and water and oxygen will it rust. That's all I'm going to say on that, because I want to spend more time on the ways of preventing rusting. Now, the ways to prevent rusting, some of them are really obvious, right? So if you've got some metal, say a metal card that you want to stop rusting, you can coat it in paint. That's one way of stopping it from rusting. You can also coat it in plastic, and paint really is a type of plastic anyway these days. So painting or covering with plastic is one way of protecting iron from rusting. You can also, if it was say a bike chain, cover it with oil or grease, and that's really good or really important when you've got moving parts. So the paint or plastic would perhaps break off or flake off if it was a bike chain. So you put grease on it and that stays on there. So that's a kind of barrier between the metal and the surrounding air and water, preventing it from rusting. What people find hard to get their heads around a bit more though is what I want to spend time on, which is the idea of sacrificial protection. Before I get to that though, I just want to mention why aluminium doesn't corrode. So lots of metals corrode when they react, but aluminium doesn't. Aluminium's quite high on the reactivity. I mentioned this in a previous video, but aluminium has a weird process by which aluminium is so reactive it will react with oxygen in the air. The substance that will form is aluminium oxide, and that aluminium oxide is quite impervious to water and oxygen. So aluminium doesn't corrode at all really, because the outer layer of aluminium very quickly becomes aluminium oxide. So it's a kind of protective layer. And I kind of mentioned that because that process is an oxidation of aluminium turning into aluminium oxide, which is very similar to iron being oxidized to iron oxide, except the difference is that the hydrated iron oxide that we call rust flakes off, peels away, and therefore exposes more iron underneath, which can then rust. The difference being that aluminium forms this kind of impervious layer. I also wanted to mention here that one of the ways of protecting iron from rusting or steel from rusting is to put chromium into the iron. Just a small, I think it's about 1% or 2%. I don't think it's very much, but the chromium does something very similar to aluminium. So steel, the reason that stainless steel doesn't rust is because the chromium forms an outer layer of chromium oxide around the outside of the iron, stopping the iron from being exposed to oxygen and water. So there's some links there, which is why I mentioned the aluminium. So stainless steel doesn't corrode because it's got an outer coating of chromium oxide. Right, so as I said, you can prevent rusting with the barrier of either paint or plastic, but you can also coat it with an unreactive metal by using a process called electroplating, and that might be something like silver. So you put silver, you get a piece of, I don't know, maybe a piece of jewellery. I don't know why I've drawn the piece of jewellery as a box. There we go, there's a piece of jewellery that could be a lovely earring for you. And if you didn't coat that in something, maybe it would rust after a bit of time. So you coat it in silver, and that's fine, that would work quite nicely. The problem with that is if that were to scratch at all, which you could do, the iron underneath would be exposed to the air and the oxygen and the water again, and therefore would eventually start to corrode. But sacrificial protection works in quite a different way. So this is where I wanted to spend a majority of the time now. So what you do with sacrificial protection is you add another piece of metal. So this is a railway track, let's say. And what you do is you strap to or stick to the ship or the pipe underwater, or the railway track in this case, a reactive metal, and that reactive metal would typically be zinc or magnesium. Notice it doesn't need to coat the whole thing, although you can do that, and that process is called galvanizing. We'll talk about that in a second. But if you just strap some zinc or magnesium to the railway track, or to the ship's hull, or to the pipe underwater, or whatever it might be, the track will be protected from rusting. And that's because the zinc is more reactive and the magnesium is more reactive than the iron. So what happens is the zinc or magnesium are oxidized in its place. And so oxidation, remember, is loss of electrons. So this process takes place. So the zinc turns into zinc 2+ instead of the iron turning into iron 2+ or iron 3+. Whoops, I made a mistake there. It should be a +2 electrons. Or the magnesium turns into magnesium ions, +2 electrons. And so you can see here that the magnesium or the zinc is being used up, is being sacrificed instead of the iron that makes up the railway track or the boat or the pipe underwater. So this might be zinc oxide, this might be magnesium oxide, but the key thing is you understand that the iron or the zinc are being oxidized in place of the iron. Now, the kind of genius bit of this may be going a little bit beyond what you need to know. The kind of genius bit of this is it works even remotely, even at a distance. So let's say some iron atoms over here, some way away from the zinc or magnesium block, become oxidized, or they get exposed to oxygen. And so the iron turns into iron 2+, let's say, temporarily. What will happen is that electrons, because this is a metal, electrons are delocalized and can flow. Electrons from the zinc or magnesium will move over to there, reversing this process, forcing this to go back into the direction. And while that's happening, the zinc will turn into zinc 2+ and give away 2 electrons. So the zinc will react instead of the iron, even if it's remote, even if it's not directly underneath. And this is a really, really important and powerful process, and it's why something like a galvanized nail, which is a kind of classic thing they ask in exam questions, where you've got, so galvanization is coating with zinc. Now galvanized nails don't rust even when they're scratched, because you've got zinc all over the place, and zinc acts in a sacrificial way. The zinc will be oxidized whether or not it's coating or covering the nail. Final point then on this is that this is obviously the bags or these lumps of zinc or magnesium would need to be replaced every so often, of course, because they'd be used up, they're being sacrificed. So you just come along once every few months or something and replace those blocks. That's it.